Hello everyone. Today I am going to explain a project on Internet of Things based on home automation. Myself Abhishek Malviya and I am grateful to emertxe Information Technology for providing me such great opportunity in their company. So moving on forward, first we start about our project introduction. Home automation refers to the automation of various activities and daily tasks performed in any household. A home automation system will monitor and/or control home attributes such as lighting, climate, element, system, and appliances. It may also include home security such as access control and alarm system. Be connected with the internet. Home devices are in the important constituent of a Internet of Things. The home automation market was worth 64 billion US dollar in 2022 and it is projected to grow over 163 billion in 2028. Now moving on forward, first firstly we see the contents. First we learn about C programming and then the project requirement, design, Arduino programming, peripheral programming and the interfacing. And then we learn the project implementation and after that the simulation. So let's first of all understand the C programming. In the C programming we learn about the C programming. Basically C programming is a low level language and it is also a primary language and which is also called a machine language. C programming language is used for the programming of an embedded system. We learn we learn its data types, conditional construct and operators, arrays, pointer functions, and also learn about do loop, while loop, for loop, recursion, constant with the pointers and strings. And we also learn about storage classes and UDT structures. Now moving on forward, in the next session we learn about the project requirement, designs and Arduino programming. First first the introduction about Internet of Things. Then we see the our project requirements, and then the introduction to the embedded system and LED programming with CLCD interfacing. So the Internet of Things definition. The network of a physical object that contain embedded technology to communication and interact with the internal state or the external environment. Basically, we are controlling the device. Basically, we are controlling devices with the help of internet, and we can say that the electronic or electrical devices through the internet we can easily control them remotely. So what is the Internet of Things? What is? So it is unique object connected to the internet. It devices. We are not connecting peoples. We are connecting devices. It is bi-directional and communications. Large complex data flow. New type of insights. For, there is lots of challenges faces in the IoT embedded system. First is addressing. Because of large data, we find the difficulty to address each or every data, so it's challenge to IoT. Later that the scaling and the connectivity. After we see that before the 4G and 5G launches in the era of 2G, there is a slow connectivity to the internet, and very few people are used it. But nowadays it's not like data volume and devices size. Because of IoT, Devices or images systems are supposed to be small in size because they may be mobile or portable. That's why their size should be small. So again, it is challenging to IoT now for the solutions of addressing. By using publisher and publisher subscriber module, we overcome this problem of addressing. That is, any publisher whenever it wants to publish a new content, it may just publish to the platform and just like and to the subscriber who are connected to the publisher not directly through the module, it will get connected easily. Now the problem of scaling means the amount of data we need to store. Sometimes we need to store less amount of data and sometimes we store large amount of data. So this problem is overcome by using cloud storage. Nowadays very popular. Now it is very popular, and the connectivity is, and after that it has a connectivity issue. So the connectivity issue can be resolved by also cloud storage. Now a device size seen ever in every mobile, the in phone we use HTTP protocol whenever it is heavier. But if we use protocol like AMQP and MQTT, this protocol drastically reduces the size of devices. Moving on forward, now embedded system. Embedded system is the combination of computer software and hardware which is either fixed in a capability of a programmable. And embedded system can be either an independent system or it can be a part of a large system. It is mostly designed for specific function within a larger system. For example, a fire alarm. It is a common example of an embedded system which can be sense only smoke. Is IoT structure divided into four stages uh, in which the embedded system come under the sensing layer where the physical object and sensors and actuators are present, in which physically collect the data to perform any task. Now after that it is transmitted to the internet through the network layer, in which internet gateways are present. After the transmission of data, it's sent to the cloud storage, in which the processing unit will analyze the data and make decision, which and it transfer to the application. After that, the data sent to the application layer where any user or the managing committees can be directly see or manage this data. Now moving forward, our project are requirements. First is the garden light control. Controlling garden light based on their intensity, sunlight, brightness, sunlight, laser, the intensity. Temperature control system. Remote control of a heater and coolers. Switching on the cooler when the turn off the heater if indoor temperature rise above 35 degrees Celsius. Water inlet and water outlet valve control. Remote control of a level of a water inside the tank. If the water level falls below 2000 liter, turn on the inlet valve and switch off the inlet valve when the tank is filled up. Tools which we are used in our project. First is Arduino IDE, second Picsimlab virtual serial ports and blynk mobile application. Now this is how our project will look like. See what we are going to do. We are interfacing ID number with the internet seal for the connectivity to the connecting to the internet, and through this we are going to control garden light for the system, temperature control and a system of a household, also the water tank and inlet and outlet going through it. And this we are going to control through the blynk application, through the through blynk application through the cloud server, and however the mobile application. This is now the project implementation. Sensors, actuators and interfacing, serial tank interfacing, blynk application interfacing, project implementation. So this is a block diagram of our project. We interfacing CLCD display, which we are going to will display about the temperature, volume of our home and of our home and the volume of tank water available in the tank. And also we are going to connect it to the temperature system through which we are going to control heater, cooler, sensors, atmospheric temperature, which we are display in the CLCD, and it connect to the internet. We are going to use internet seed as it does not have do not have any connectivity for the internet, so we are going to use internet seed dependent seed, and it is also we are using for the garden light dependent register, which is sensed to detect light intensity in the atmosphere. If the intensity of a light decreases, that is darkness, it come and it will turn on the garden lights. That's our LED, and when there is sufficient light, the outside atmosphere, it will turn off. It is based on the LDR. So that is our sensor interfacing, and this is serial tank interface. We are going to control virtually with the help of virtual components. Now moving on forward, it is blynk application interfacing, in which is data string there, in which all the connections, cooler pin, temperature sensor, heater button, water tank, inlet valve, outlet valve, and notification connections are connected. So in the final, we learn about Disha workshop. In the Disha workshop, we learn about resume making and scope in IoT and embedded system domain, which is very helpful to our future. Now we are going to see the simulation. So this is our project code in the Arduino IDE, and this is a Picsimlab. Here we are virtually simulate the hardware and see the output of our project, and this is our serial tank, and it is also our it is also virtually connected. So again this is our serial remote tank, and this is our serial remote tank, and we are connect this is blink application. Just we like to turn on, just I turn on the heater. So if I turn on the heater, the temperature is increasing. It is so that the temperature increase, sorry, this temperature is increasing. It will rise till to the 35 degrees Celsius. As you can see that in the notification temperature in the notification, if the temperature above 35 degrees centigrade, now if the heater will turn, now water is heater is automatically turned off. We have designed in such a way that the temperature will go beyond 35 degrees Celsius. It will turn off automatically, and the temperature started, the heater get turned off. Now if I turn on the cooler, the temperature is decreasing drastically. If I turn on the cooler, now you can see that Now you can see that the fan is start rotating and the temperature is decreasing. If I turn on temp both heater and cooler, temperature is not the temperature is not rising and the temperature is constant. Now the serial tank. As you can see that the outlet valve is full. The outlet valve is the inlet valve is open and the volume is going to be filled fully. The serial tank is filled full. Now if I open the outlet valve, the volume of a volume of water in a cereal tank get decreasing, and it will decrease up to 2000 unit. If 2000 unit is reaches, the inlet valve is automatically on, and it will going to fill it. If I off the outlet valve, then the inlet valve is going to fill, and if tank is full, the inlet valve is automatically off. Now you can see the temperature in the CLCD screen and the volume of a inlet of a cereal tank in CLCD screen. And we are also controlling the garden lights through the LDR. If I decreasing the resistance, if I increasing the resistance, the garden light will be turned on. If the light in the atmosphere will have it, it will turn off automatically due to the light dependent resistance. So this is our project. Thank you for listening.